Okay, now the last section of this chapter is chapter 2 is regarding Bernoulli equations. Bernoulli. So we just remind the general form and how to solve it. Now this is the general form. We have y prime plus px y and then equals fx times y power n. When here n can be any real number. And to solve a Bernoulli equation, you just need to do a substitution u equals to y power 1 minus n. Now, sometimes what is happening is you don't see the form. You need to do some steps, some work to see that it's a Bernoulli equation. Now, I'll just give an example. Let's say we have y squared y prime minus 2x y cubed equals x. Now, to see a Bernoulli equation, we need to divide first by y squared. So we have y prime minus 2x y, and here we have x y power minus 2. So here it's the Bernoulli with n equals to minus 2. Then we do the substitution u equals to y power 1 minus 2. That means y power 3. Now, once we do this substitution, the first thing to do is to find the derivative du over dx. We just need to remember that this is the chain rule, is du over dy and then times dy over dx. Now du over dy will be 3y squared and then times dy over dx. That means 3y squared y prime. Now that means y prime, I can write it as du 1 over 3y squared and then times du over dx, or I just write u prime. Okay, now I just need to go back to this equation and substitute y prime by this expression. So we obtain y prime is 1 over 3y squared u prime minus 2xy equals xy power minus 2. Now this is still depending on 3 variables, so we need to cancel the y. The best way is just to multiply by the coefficient of u prime. Whatever you have in front of u prime, just divide by that. That means here we need to multiply by 3y squared. So we obtain u prime. Now if you multiply by 3, that means minus 6x y cubed. And here we have 3x. Now y cubed is just u, so this is u prime minus 6x u equals 3x. Now this is a linear equation. And we just need to solve it. Now px here is minus 6x, fx is 3x. So we just apply first the integrating factor. Mu x is exponential integral of px, that means minus 6x dx. If you integrate minus 6x, you obtain negative 3x squared. And then you can write the formula for u. It means ux is, remember the formula for linear is 1 over mu x, that means exponential. Now 1 over exponential minus 3x squared will be just exponential 3x squared. Then you have to write the integral of mu x, which is exponential minus 3x squared, times fx here is just 3x dx. Now to integrate this, you just need to do a substitution, because if you say u is minus 3x squared, du will be minus 6x. Here I have 3x, so I need another minus 2. So ux is exponential 3x squared. Now this one I will just write it negative 1 over 2, and then the integral of, I divide by 2 because I need to multiply by 2, and same for the minus. So integral of minus 6x exponential of minus 3 x squared dx. Now you can see that here if you differentiate this exponent minus 3x squared, you'll obtain minus 6x. So if you write u equals to minus 3x squared, we'll obtain exponential u du. So finally, this is negative exponential 3x squared, and I'll obtain exponential minus 3x squared with negative half, and then plus a constant c. Okay, now just continues to the next. Okay, now, so just write what we obtained the previously. We had exponential 3x squared negative half exponential minus 3x squared plus c. So this is, if I multiply, it will be negative half plus c exponential 3x squared. This is u, but remember just that u is y cubed. Now here we have to pay attention. If you obtain here power which is an odd number, then we can write y in terms of u. If it is an even number, if you are not given that y is positive, then we just obtain an implicit solution by just writing, for example, whatever we have equals to this function. But here we have y cubed, so we can write that y is u power 1 over 3. So we obtain this final answer, yx is c exponential 3x squared minus half at the power of 1 over 3. So this is the explicit solution of this Bernoulli equation.